Hi, this is lesson 6 in the use of JASP. Today we're going to focus on using the plot builder with repeated measures data, data that is in wide form, the typical way that repeated measures data is collected. We have been focusing on JASP for sleep data, and this is what you get. This is long form, where Uh, any repeated measures, like the person number 1 gives a measure over here of 0.7, and then person number 1 gives another data point of 1.9 over here. We learn how to restructure that in lesson 5. So if you need to go back to lesson 5, you can do that. So I'm going to go and find from my data that we restructured on the laptop the wide form data. And in wide form, we basically have all of every person's data in a single line. All of person's 1 data in a single line, person's 2 data in a single line. This makes the data structure wider than it would be if you organized it in other ways, especially the more data that you have. So we're going to go ahead and look at descriptives, and we're going to look at plot builder. And one thing that we skipped over previously when we looked at plot builder was we didn't really pay attention to whether or not this was repeated measures or not. But this is repeated measures data, so we're going to click yes. When we click yes for repeated measures, you'll note that it automatically clicks by default a box that says what to do if you have missing data. And it basically is saying to delete missing data listwise. Let me talk just briefly about what that means. So you can think of your data structure as having a list of participants who completed the various portions of your study. And imagine that this 0.8 was missing. So if I go over here and take out the 0.8, now it's missing. And so when you click that button that says delete missing data listwise, it's not only going to delete this data point, which is already in essence deleted because it's not there, it's going to delete this case. It's going to delete all the data for person 2 that's being used in the analysis, and that's called deleting the data listwise. I'm going to go ahead and stick back in my 0.8 and continue on, but there's one little lesson on what listwise deletion means. Okay, let's go to analysis, and what we're going to do is we're going to take and put our extra hours of sleep for drug 1 here, extra hours of sleep for drug 2 here, and now it has the basis for building a plot. We're going to go to individual data points and say plot the individual data points. Again, that it's using the jittering, but I'm going to go ahead and take that off by putting in zeros. I don't feel like we need the data jittered, given that it's a very small data set. And what I want you to notice here is that we can now, this does not show up, or you can't click it. It's not highlighted so that you can click it unless you have a repeated data structure and say, yes, repeated measures. So now that we have repeated measures, we can say connect the data points. And now I have a really good representation of what's going on with this data. Everything's lined up for condition 1 or drug 1 and drug 2. And now I can see the lines connecting those. And there's no error being tossed into the data structure as a function of jittering, because jittering is adding a random component to knock the data points off their center to separate them. And so I don't see any reason to jitter the data right here when you can see pretty much what's going on without doing so. You can go ahead, and if you want to add in a box plot, you can. And I'm going to reduce the transparency of that. Another option, which we did not go over before, is to do a violin plot. People tend to like this because it's pretty and looks like a violin, more or less. It's kind of getting cut off if it wasn't getting cut off. But what it tends to do is it tends to expand where most of the data parts are and then get smaller where there's fewer data points. I'm going to go back to the box plot though. Take off the violin plot. We can put in title for our x-axis, so that is drug condition. And I think conditions 1 and 2 is fine, but it's just called level 1 and level 2. If you want to change the names up here where you put in the data, you can go ahead. So notice if you go up here, it's automatically said that this variable name was called level 1, this variable name called level 2. You can go up here and you can rename those. And so I'm going to say drug A and drug B. And that changes the names there. Go down to the y-axis. Let's make sure that this captures all the data from going from a -2 to a 6. Gives you the entire scale. If I go down to the y-axis, I can relabel that value there as extra hours of sleep. And if I want to put in a new title, I could say extra hours of sleep as a function of drug condition or drug treatment. And you can always take this and spread it out. And now it's looking pretty nice. Theme and color again, you can actually show for the grouping variable a little orientation over there. Separate the colors and play with the colors in all kinds of different ways. There's all kinds of things that you can do here that get at making those data points easier to see. So for example, I can go to transparency 0.9 and it's thicker. I can change the line width to 0.8 and it's thicker, and so then I can see how each person is changing more clearly and can see that it's pretty clear that scores are going up for each of the individuals. This one maybe going slightly down. So lots of other ways of playing with this. It's a matter of getting in and playing, but there's your basics for doing repeated measures and the advantage that you have in terms of being able to connect the, the points for the individuals and show that what your repeated measures analysis is getting at, this within subjects t-test or the multi-level version of that repeated measures t-test, what those are getting at is how each individual responds differently. See you next time.